Welcome pre-cal students to class today on this Tuesday, April 1st. Hope you guys are doing well. Hope you're ready to learn some math today. Let's go over our announcements like we usually do. Test on Monday, so you'll have a review sheet on Friday. If you're not going to make that test here at my house, I need to know no later than Sunday, please. All right. Turn in your quizzes. They are due by today, Tuesday. So your quizzes are due by today, Tuesday. All the questions all of the questions asked and all the problems worked out. Number 3, stay on top of your integrity sheets. Emphasis on integrity. Please be honest with those. And they are all going to be due on that Monday. So when you walk in my door on Monday, whatever you do not have done, you cannot do later for credit. Number 4, long video today, men. Long video today, but no homework. So that means tomorrow you will have homework but no notes. Now, tomorrow there will still be a quick 1 to 2 minute video labeled April 2nd. So you need to listen to that, and then I'll give you the homework assignment, and then you can watch the homework video if you need to with your homework. Okay, but a long video today, no homework, and then tomorrow no notes but homework only. Okay, so hopefully those announcements make sense. Let's go ahead and get started. As you have probably noticed, I am attempting to do a better job of reviewing what we have covered during a week's time. So let's quickly review what we talked about yesterday on Monday. We talked about using synthetic division in place of long division. Okay, and we talked about the divisor has to be in a certain form. This divisor here would not work. There has to be a 1 here in front of the x, and this power right here has to be a 1. This has to be a constant term, and this has to be a binomial. And when that happens, you can then put your coefficients over here, 3, 0, negative 5, 1, and 0. And then you have a positive 5 right here, so you put a negative 5, and then do your synthetic division and go from there. Synthetic division is usually shorter than long division. We also talked about using synthetic division to evaluate a function at a given value. So instead of taking 5, and this should be x cubed here, this should be x squared, instead of taking a 5 and putting it in everywhere there's an x like this, you're going to use synthetic division. You put a 5 right here, do your synthetic division, whatever number you get here at the end is the answer. All right, so that's a quick review of what we looked at on Monday. Today, we are going to be looking at a very interesting topic. Of course, I think that all math is interesting, but that's just me. So far every time, sorry guys, excuse me. So far every time I have asked you to find the zeros of a polynomial function, the polynomial has been a factorable function. Okay, so you put a 0 in for y, and then you factor the right side, and you found the zeros. What would you do if the function looked like this? You say, well, I'd factor it, Mr. Hart. Well, go ahead and try. Pull out what's common in the first two. Pull out what's common in the second two. And look, your parentheses don't match. And so you cannot factor this using the grouping method. So what are you going to do if you tried to factor it? You would see it can't be factored like I just showed you. What are you going to do when you go to find the zeros of this function? You put a 0 in for y, and then you can't factor this side. Today, we are going to learn what to do in those situations. All right. Let's start off first of all, though, by looking at what a rational zero is. This is very important. We need to really understand that there is a difference between rational zeros and irrational zeros. So let's start off by doing that first of all. Rational zero is less than 3.4, and the date today is 4/1. 4/1. Okay? Rational zero is less than 3.4, and the date today is April 1st. Now, I would like you to copy this down in your notes, please. F of x equals quantity x plus 5 times the quantity x squared minus 3. Now, let's go ahead and find the zeros for this polynomial function. Okay, that's easy enough. Whenever I ask you to find the zeros, I'm really asking you to find the x-intercepts. And if I'm asking you to find the x-intercepts, then that means you put a 0 in for y. So you put a 0 right here. Now we take x plus 5, set it equal to 0 and solve, and we get a negative 5. Then we take x squared minus 3, set it equal to 0 and solve, bring the 3 over and make it a positive 3, and then take the square root of both sides and we get positive negative square root of 3. This number right here, negative 5, is a rational zero because negative 5 is a rational number. We studied this the very first week of school. We talked about rational and irrational numbers. Square root of 3 is an irrational number. Now you might say, well, Mr. Earhart, that's been a long time ago in the month of August that we talked about this. Could you refresh my memory? Certainly. A number that is a whole number, positive or negative, or 0, or a fraction, any fraction that has integers, 1/2, 2/3, or any decimal that terminates, like 0.5, or any decimal that repeats, like 0.3 repeating, all of those are rational numbers. However, when you take the square root of 3, look what you get. The square root of 3 is this. It's 1.7320508808 and then on and on. It is non-repeating and it's non-terminating. In other words, the decimal continues on and on and on, number 1. And number 2, it never repeats. Even here, it's really not repeating. It was probably rounded up to an 8, and it would not repeat. It would not keep going 0808, trust me. So the square root of 3 is non-terminating. It doesn't stop. It's non-repeating. And so it's irrational. And so what I wanted to show you, first of all, very quick, I thought it was very important to do this, is I wanted to show you the difference between rational and irrational zeros, okay? When you're solving for the zeros of a function and you get out whole numbers and fractions, those are going to be your rational zeros. When you get out square roots like this, these are going to be your irrational zeros. You need to know that as we talk about that today. Okay, let's continue on. There is a way to look at a polynomial function that is written in standard form. Listen to this, it's so cool. And make a list of possible rational zeros that the function might have. So we'll go back up to this example here. Caleb, Matthew, think about it. We couldn't factor this, so we have no idea what the zeros are. However, what if I could make a list of numbers for you to test and see if any of those numbers were a 0? That would be really beneficial. In other words, if there were any rational zeros, they would be in this list right here that I gave you. That would be a big help because then you could take this list of numbers. Remember how you put each one in and see if it gives you out a 0? That would be a big help. So there is a way to look at a function written in standard form like this and make a list of the possible rational zeros that the function might have. Let me show you how to do this. All right, go ahead and copy this in your notes. Take the function below for an example. It is a 5-term polynomial function. Go ahead and copy this in your notes. So factoring it is not an option. We have never learned how to factor a 5-term polynomial expression, and to be honest with you, they're really difficult to do. Now, the actual rational zeros for this function are -2, 1, 4, and 1/2. Now, Mr. Earhart, how'd you know that? Don't worry about that. I just want you to write that down. These are the actual rational zeros for this function. In other words, if you were to graph this, if you were to type this into your grapher and hit graph, you would see that the graph would cross the x-intercept at -2, +1, +4, and +1/2. These are the actual rational zeros for this function. Now let me show you something. I want to show you how to list out or to make a list of possible rational zeros for polynomial functions. Now here's what you do. Please take some really good notes. First of all, you list out all the factors of your lead coefficient. Now remember, you need to make sure your polynomial is written in standard form, and if it is, this is your lead coefficient. So you list out all the factors of your lead coefficient. Well, the only factors of 2 would be 1 times 2. Now you go to your constant term, and you list out all the factors of your constant term. Well, that would be 1 times 8 and 2 times 4. That's easy. Which one of you two students could not do those two steps? That's so easy. Both of you can do that. List out the factors of your constant term, all of them, list out all of your integer factors for your, or excuse me, for your lead coefficient over here, and then for your constant term. That's easy. Now, what we do next is still pretty easy. You take the first number here, in this case it's a 1, and you put it on top of each of these numbers. So 1 over 1 is 1, and 1 over 2 is 1/2. Now you're done with 1. Cross it off. Now you do the same thing with your 8. 8 over 1 is 8, and 8 over 2 is 4. Cross that off. Now you use the 2. 2 over 1 is 2, and 2 over 2 is 1, and we already have 1 written down, so we're not going to worry about writing that. And now we deal with the 4. 4 over 1 is 4. We already got that. And 4 over 2 is 2. We already have it. So here's your list. Now there's only one more thing to do, and that's to put plus minus in front of each of these numbers. And guess what you just did, Matthew Kidd? This is so cool. What you just did is you made a list of all of the possible rational zeros for this function. Now please listen to me. I am not saying that the function has to have a rational zero. Did you get? Let me say it again. I'm not saying that this function has to have a rational zero. Maybe it does, maybe it doesn't. But what I am saying is this. Are you ready? Here's a big word. If. If this function has any rational zeros at all, every single one of them will be in this list somewhere. Every single one of them. And remember, I already told you the rational zeros for this function are right here. Is -2 in this list? Yes. Excuse me. Is 1 in this list? Yes, right here. Is 4 in this list down here? Yes, right here, +4. Is 1/2 in this list? Yes, right here. Now, I understand something. If I can read your mind, you're thinking, Mr. Earhart, what if you didn't tell us that these zeros were the zeros? The only way for us to know is to test these numbers until we get out a 0. And you're right. And that can take some time. But I'm going to show you later another shortcut before this video is over. I'm going to show you a shortcut that's going to help you with that, okay? So keep that in mind. But the main thing I want you to learn right now is how to make a list of, now listen to me, not rational zeros, but possible rational zeros. Okay, all of these numbers are not zeros for this function. But if there are any rational zeros for this function, they will be in that list right there. Let's try 2 more so we really get some good practice in, okay? Let me get a drink here, and we'll continue on. Okay, you can work ahead or watch me. I want you to list out the possible rational zeros for this function. Here we go. First of all, is it written in standard form? Yes, it is. So we list out all the factors of our lead coefficient. Well, 1 times 3, that's all the factors. Now we go to our constant term. We're going to list out all the factors of 4. So 1 times 4 and 2 times 2. Now there's no need to put 2 twice, so we're not going to worry about that. And so there, I've listed out all the factors of 3. I've listed out all the factors of 4. And now you take your first number, which is a 1, and put it on top of each of these numbers. So 1 over 1 is 1, and 1 over 3 is 1/3. There, I'm done with that. My next number is a 4. Okay, I put 4 over 1, that's 4, and 4 over 3 would be 4/3. Okay, I'm done with 4. Now use your 2. 2 over 1 would be 2, and 2 over 3 would be 2/3. And now don't forget, here's what a lot of students forget to do. You put a plus minus in front of each of these. And there we go. Look at that. Now I'm not saying that this function right here that I'm getting ready to circle in 1 second, I'm not saying that this function right here has any rational zeros. There are some polynomial functions that have no rational zeros. But if there are any rational zeros that exist for this function, they will be somewhere in this list. Now irrational zeros, remember, let's go back. Remember, an irrational zero, if I can find that real quick here, I think it's one more page back. Remember, an irrational zero would be like this. And never, please listen to me, never will your irrational zeros appear in this list. Never. So this function right here, this function might have an irrational zero of plus minus square root of 8. Okay? And that's fine. That means you have two zeros for this function. But it would not be in this list because this is an irrational zero. Listen, a polynomial function can have irrational zeros, or it can have rational zeros, or it might have no zeros at all. Okay? This list here is for rational zeros only. Okay? Let's try one more. Again, you're welcome to work ahead, pause the video and try it on your own and then start the video, or you can watch me. Let's list out the possible rational zeros for this function right here. Now, first of all, is it written in standard form? Yes, it is. So secondly, what is your lead coefficient? 2. So we're going to list out all of the factors of 2. 1 times 2. Now, the constant term is 15. So we're going to list out all the factors of 15. Well, 1 times 15 and 3 times 5. There we go. And now that we've done that, we simply take each one of these numbers here, one at a time, and put them on top of all the numbers over here. So here we go. 1 over 1 is 1, and then 1 over 2 is 1/2. Okay, that number's gone. Now 15. 15 over 1 is 15, and 15 over 2 is 15/2. Now the 3. 3 over 1 is 3, and 3 over 2 is 3/2. And now the 5. 5 over 1 is 5, and 5 over 2 is 5/2. And now just don't forget to put your plus minus in front of each number, if we can get the pen to work here. And I'm not saying that this function has any rational zeros. It might not. But if there are any rational zeros in this function right here, they will be in this list right here. Now that's step 1 in helping you learn how to factor and find zeros of these problems that are not factorable. Step 1 is you must know how to list out the possible rational zeros. Okay? Let's continue on. And by the way, men, I'm really sorry about constantly clearing my throat. I just did have something to eat, and I believe it's just kind of, my throat's a little dry, so I do apologize. Okay, now let's take a look at these last two. Let's take those last two functions that we just dealt with, this function here and this function here. Let's take those last two functions, and let's find all of the real zeros for those two functions. Okay, so here we go. Go ahead and copy this in your notes, and let's find the zeros of this function. Now pretend you're taking a test, and on the test I said find the zeros of this function. Well, you should know by now, the first thing you're going to do is you're going to put a 0 right here, and you're going to try to factor. So we try to factor this, and trust me, it won't work, so we can't factor it. So the next thing we do is we list out all of our possible rational zeros, right? I mean, if we can't factor it, we've got to start testing numbers to see what we get. So here are the possible rational zeros right here. Remember, I already found them. If you're taking really good notes, you should have a record of those already. And so here's the possible rational zeros. Does that make sense? And now common sense says you're going to have to start testing each one of these, okay? And that's not going to be fun, but it is something that we need to do, okay? So, give me just a second. I do know what I'm doing, but I'm looking for something here. Okay, I'm going to test -1 first. Why? Because I feel like it. Now, do you remember how? No other reason. Now, remember how to test -1? Remember how to test a real fast way to test a number to see if it's a zero function? Man, it's really fast. Put -1 right here. Bring all your coefficients down. A 3 for the x to the 4th, a -11 for the cubed, a 0 for the squared term, a 10 for the x term, and a constant term. And watch how fast I do this. Bring down your 3, multiply -3, combine -14. Multiply, it's a positive 14, combine, you get 14. Multiply, you get -14, combine, and you get -4. Multiply those, and you will get a positive 4, which would give you a 0. Now, I'm going to be totally honest with you. I did not mean I did not mean to get a 0 out. So I am a very lucky person. Okay, I'm kidding. I don't believe in luck, but I'm very fortunate. I was hoping to get a number over here like 8, and I was going to say, okay, -1's not one of your zeros, so cross that off. Let's try another number, but it didn't work, so that's fine. We'll go with it. So we tested -1, and I got out a 0. Now, would you please let me help you? You're thinking, Mr. Earhart, the highest power is 4. That means I can have 4 zeros. I've got to keep testing all these numbers until I find 3 more? No, no, no. Not if you'll use this shortcut I'm about ready to show you. Are you ready for this? This is really, really, really neat. One of your zeros was what? We just found it right here. You put -1 in and you got out a 0 using synthetic division. So one of your zeros would be what? -1. Now just take what's left over here. Take what's left over and let me show you. After you've taken the -1 and you've done the synthetic division and you're left with this, it's just like long division, only remember what we do? The highest power here, I know it wasn't long division, guys, I get that, I know that, but watch. After you divide a -1 into it or use synthetic division and get out a 0, what you're left over with is the rest of the polynomial that you want to try to find the zeros for. So you did have an x to the 4th up here, so remember you start with the next. We learned this a couple days ago, maybe yesterday. You start with the x cubed, x squared, x, and then constant terms. So now you're left with this. Now you're left with 3x cubed minus 14x squared plus 14x minus 4. Now why is that helpful? Because I've taken this expression and I found that -1 went into it evenly and gave me out a 0, so I know it's one of my zeros. So now, instead of using this expression, now I'm going to use the leftover expression from right here. And why is that a big deal? Because maybe I can factor this. I couldn't factor the original problem. Maybe I can factor this. And if I can, it's much faster. Well, I got some bad news for you. You can't factor it. If you pull out what's common in these two terms, and if you pull out what's common in these two terms, you are not left with matching parentheses. So we're not going to be able to factor it, okay? So because we can't factor the leftover polynomial here, then what we're going to have to do is test some more zeros from up here, okay? So here we go. And by the way, just so you know, sometimes the -1 can work again, because don't forget, sometimes when you're done with your factoring your polynomials, you'll have multiplicity like that. So don't think that you couldn't use -1 again. Now, I don't think you can in this problem, but you never know, okay? I'm going to try another number. I'm just going to try, I don't know, 2. Let's try +2 and see if we get out a 0. So my x cubed term is 3, my squared coefficient is -14, my x coefficient is 14, and my constant term is -4. Let's see if I get a 0 out over here. Here we go. Bring down your first number, multiply, you get a 6, combine, you get a -8, multiply, you get -16, combine, you get a -2, multiply, you get a -4, combine, and you get a -8. So it didn't work. And so we'd have to go through as long as this sounds, and it can take a while, you have to continue going through your list. Now, because I have the book and I can cheat a little bit, I do know another 0 is 2/3, so that's right here in your list. So let's go ahead and put 2/3 here. Let's pretend we're testing 2/3. Take some notes on this, and let's see if we get a 0 out, because I want to show you what happens once you get a 0 out. Okay, bring down your first number. It's 3. 2/3 times 3 would be 2. -14 and 2 is -12. 2/3 times -12 is -8. Combine and you get 6. And 2/3 times 6 is a +4, which gives you a 0. So it worked. So now come up here to your list. You know one 0 is -1, and now you know your other 0 is 2/3. So now, instead of being left over with this group right here with this 0, now you're left over with this group because of this 0 right here. So now you're left over with this group. So we're taking our original problem and we're kind of butchering it and cutting it down until it's getting smaller and smaller. So what was the degree that you used right here in your top row? Wasn't your degree a 3rd degree? Sure it was. So you go one less and you have 3x squared minus 12x plus 6. Let's write that right here. 3x squared minus 12x plus 6. Maybe we can factor this. You never know. You never know. Let's try and see. Okay, so first of all, when we go to factor this, we pull a 3 out first, and we're left with x squared minus 4x plus 2. All right, very good. Now we say to ourselves, okay, self, I've got a trinomial here, a lead coefficient of 1. What two numbers when multiplied together give me 2, but when added together give me -4? Well, there are no two numbers. And so the problem is, let me get a drink here real quick. The problem is we can't factor it, so how are we going to find the zeros? Are you like, oh, I know, Mr. Earhart, let's keep testing numbers from our list. You could do that, but remember, anytime it's a quadratic, and this is a quadratic, you have your x squared term right here, and it's your highest power. If you can't factor it, you could use the quadratic formula on it. Okay, and so I'm not going to take time and do the quadratic formula on this for you. Okay, I'm not going to do that. I'm going to put that back up here real quick. There we go. Because we know how to do that. It takes quite a while, and I don't want to insult your intelligence. But if we were to take this trinomial right here, your quadratic trinomial, a would be what? A would be 1, b would be -4, and c would equal 2. If you use the quadratic formula on that, please trust me, you would work it out and you would come down to this right here. After all of your work, take notes on this if you would, please, guys. You would have, just make notes that, put something like used quadratic formula and came up with this. You would come up with this, and then a can be broken down. We don't know the square root of 8, but a can be broken down into 4 times 2. 4 times 2 is 8. Cross off the 4 and put a 2 right here. So now you have 4 plus minus 2 square root of 2 all over 2. And notice how all of your outside numbers are reducible or divisible by 2. So 2 goes into 2 once, 2 goes into 2 once, 2 goes into 4 twice, and you're left with 2 plus minus 1 square root of 2 all over 1. Or in other words, 2 positive negative square root of 2. And those are your last two zeros right there. And by the way, notice they're not in your list. These two zeros, 2 plus the square root of 2, 2 minus the square root of 2, these are not on your list because they're not rational. Remember, this list only has lists of possible rational zeros, and this zero right here, these two zeros, are irrational zeros. So you did find the zeros. We did it. Here are the zeros, your final answer. Your zeros are -1 comma 2/3 comma 2 positive negative square root of 2. That's 4 zeros. 1, 2, and there's 2 right here. 3, 4. So what was the degree of your original equation? 4. So what's the maximum number of zeros you could have? 4, and that's what we have. Okay, so we did it. We made a list of possible rational zeros, we tested them, and then we found a couple, and then we kept breaking it down step by step. Okay, let's try one more of these. Let's get some space here real quick, and let's try one more of these. Alright, and here we go. Alright, let's find all of the real zeros of this function. Now, first of all, you would put a 0 here because you're looking for the zeros or the x-intercepts. So you put a 0 in for y. Now next, you would try to factor. We've never learned how to factor a 6-term polynomial function. So since we can't factor this, we have to list the possible rational zeros. Now they should have been back here somewhere. Here they are right here. Here are the possible rational zeros that we found earlier for this function. So there's our list. Now I know what you're thinking, Mr. Earhart, you're crazy, it would take forever, and I agree, but on a test or a quiz I might give you a hint. Plus, in just a couple seconds, look ahead here, I'm going to show you some tricks that will help you understand how many negative and positive rational zeros, or irrational zeros for that matter, you might have. So we're going to get into some more helpful hints here in just a minute. But for now, we're going to go with our long list of numbers. Now it looks like you have a lot of numbers to test. 1, like the 1 here, there's 2 numbers there, plus minus, there's 2 numbers here, plus minus. So we have 1, 2, 3, 4, 6, 8, 10, 12, 14, 16 numbers here that are your possible rational zeros. Okay, and that's quite a bit. But because I do have a little bit of help here with the answer key, I'm looking here, I can tell you right now, first of all, that one of your possible rational zeros is going to be 1/2. I mean, that one of the zeros that's going to work is 1/2. And notice it's in your list here. So would you go ahead and take some notes, and let's test 1/2. So here we go. Notice your function is written in standard form, so we're good there. The coefficient of the 5th degree is a 2. The coefficient of the 4th degree is a -1. Third degree coefficient is -4. Second degree coefficient is a +2. The x coefficient is a -30, and you must have a constant term. If you don't, you have to put a 0, and we do have a constant term. It's a 15. Now let's watch what happens here, okay? Bring down your 2. 1/2 times 2 is 1. Combine and you get a 0. 1/2 times 0 is 0. Combine these two numbers, you get a -4. 1/2 times -4 is -2. Combine and you get a 0. 1/2 times 0 is 0. Combine these two numbers, you get a -30. 1/2 times -30 is -15, and you get out a 0. Now that's pretty helpful. So I'm going to come way down here in the corner, and I'll come way up here. I'm going to come way up here, and I'm going to put zeros equal, and I'm going to put 1/2. I found 1 0. Now remember what that did for you. It took your original problem and it made it smaller. Now we can say I started off with an x to the 5th, so this is an x to the 4th, this is an x cubed, this is an x squared, this is an x, and this is your constant term. So I don't need those zeros, so what I really have now is this. Look, 2x to the 4th minus 4x squared minus 30. I don't need my 0x cubed. I don't need a 0x. Look what you did. You took this real long problem, and as soon as you found a 0, which you did, you could then take the leftover or the remainder and now work with that and forget all the rest of this stuff, okay? So now I'm going to work with this polynomial function to find the rest of the zeros. Let's see how we do. Always try to factor first, so let's see if we can't factor this. Maybe we can. Maybe we can't. Let's find out. So, first of all, let's pull out what's common. Let's pull out a 2, and we're left with x to the 4th minus 2x squared minus 15. Let's check and make sure we're right. 2 times x to the 4th, 2x to the 4th, 2 times -2, -4, 2 times -15, -30. So we're left with a trinomial. Remember what I've taught you. If it's a trinomial, which it is, and this exponent here is twice as big as this exponent here, which it is, and we have a constant term here, which we do, then we can factor it using our quadratic rules. So, what two numbers I have a lead coefficient of 1, that's the easy type of factoring. So, what two numbers multiplied together give me a -15, when added together give me a -2. Oh guys, look, -5, +3. When you multiply those, you get a -15. When you combine those, you get a -2. So now, finding the rest of my zeros becomes pretty easy. Now remember, you don't put x minus 5. You use your middle term variable. It's x squared. So x squared minus 5, and then x squared plus 3. You did it. You broke the remaining part. This is the remaining part that we had left over, this and this. You took that and broke it down to factors. Now, can you not very quickly find the zeros for this? Well, we're going to take x squared minus 5 and set it equal to what? 0. Take x squared plus 3, set it equal to what? 0. Now bring the 5 over and make it a -5 or +5. So x squared equals 5. And now take the square root of both sides. So x equals plus, minus, or positive, negative square root of 5. So there's 2 more zeros. You can add to your list. Put them on up here. Here we go. So now we have 1/2 as one of your zeros, and now positive, negative square root of 5 is one of your zeros. Now let's see if we can find the zeros for this. Bring your 3 over and make it negative. Now take the square root of both sides. X equals positive, negative square root of -3. Well, we know we can't take the square root of a -3, so we're going to get rid of that negative sign and make it positive, and we're going to put an I right here. So there's your other 2 zeros right here. So there we go, we did it. Now, let's circle your answer, and your answer is not completely right. And let me show you why. Read the directions carefully. Let's find all of the, what's that say? Guys, can you say that? What's it say? Let's find all of the real zeros. So these two zeros here really shouldn't be part of your answer because these two zeros are imaginary numbers. They don't exist. They're not real zeros. So I would cross this off. Even though it is technically one of your zeros, it's an imaginary zero, so we're not going to use that. Here's your two real zeros. Now, which one of these is a rational real zero? 1/2. Which one of these two zeros, there's really 3 zeros, sorry, I should say 3. Which one of these up here is a rational zero? 1/2. Which one of these zeros is an irrational zero? Well, positive, negative, square root of 5 is irrational. So you have one real rational zero, and you have two, because of the positive negative, you have two irrational real zeros for a total of 3 real zeros. Both of these are real. This one is rational, this one is irrational. So hopefully you're getting the hang of this. It's not easy, and now you see why the video today is just a video. No homework. I want you to spend this video should be about an hour long or maybe a little shorter, and you study it, take good notes, really understand it, play the video back, watch different portions again that you don't understand, and then really get grounded in this. Then tomorrow we'll do some homework, okay? One more quick topic to look at and we're finally finished. One more topic you need to be familiar with. Descartes' rule of signs, lesson 3.4. Descartes' rule of signs, lesson 3.4. This is his last name, and he's the one that came up with this. Descartes' rule of signs gives you some hints about how many positive real zeros you can have and how many negative real zeros a function can have. I'm only going to give you one example of these types of problems. So please take really good notes. Okay, here we go. Here's your one example. Use Descartes' rule of signs to tell about the number of positive and negative real zeros the given function has. Okay, here's what you do. First of all, you make sure the function is written in standard form. Take some good side notes here, okay? I really don't have steps written down for you because it's really a simple procedure to do. First of all, make sure it's written in standard form. Then secondly, all that you do is you go from term to term to term to term, and you're looking for sign changes. That's it, Mr. Earhart. That's it. You're just going from term to term to term to term looking for sign changes. So my first term here is a positive or a negative. What is this term? Well, it's positive. So I went from a positive to a what? Negative. Well, that's one sign change. Put a tally mark over here. Then I went from negative to negative. Is that a sign change? Not at all. And then I went from a negative to a positive. That's another sign change. So how many sign changes did I have? 2. Now here's what that means. Please take some really good notes. That means that this polynomial function right here, the one I'm circling over and over and over, what this means is this polynomial function has 2 or, are you ready? 0, I'll explain why in a second, just write this down. This polynomial function right here has 2 or 0 real positive zeros. Now, how'd I get 2 or 0? Well, you already noticed that the sign change is going across. There were 2. So that's where the 2 came from. And then what you always do is you keep subtracting the number 2. I don't care what this number is here, men. I don't care what this number is. You subtract the number 2 over and over and over until you come to 0 or until you come to a negative number. So for example, would you just humor me for a second? Let's pretend we had looked at all the sign changes, and let's say there would have been 3 sign changes. Then you would put 3 or, and you subtract 2, 1, and then you're finished. You can't go any further because you'll go into negative numbers. So you would know that you have either 3 real positive zeros or you have 1 real positive 0. Now, Mr. Earhart, how would that be helpful? Are you kidding? You know for sure you have 3 or 1, so you know for sure you have 1 real positive 0. So if I'm going to be using my list of possible rational zeros, I'm going to try to find that positive 0 if at all possible. Now, there might be 3, but I know there's 1 for sure. And then if I go along and I find another positive 0, that's 2, then I know there has to be a third one. Because I'm telling you now, if there were 3 sign changes going across, then that means you have 3 or 1 positive real zeros or real positive zeros, okay? So in this, let's say the number would have been 5. Let's say there were 5 sign changes. Then you have 5, or you have 3, or you have 1. Notice I keep subtracting 2, okay? You have 5 or 3 or 1 real positive 0. What if my sign changes had been a 6? Okay, then you have 6 or 4 or 2, or it could be a 0 or 0, okay? So you have 6 for sure, or 4 or 2 or 0 real positive zeros, okay? So that's how you check. That's how you check to see, to get some hints about your positive real zeros. Now, what about the negative real zeros? Okay, here's what you do. I'm sorry, guys. I want to go back to that last problem real quick. I apologize. So back to this problem we were just doing. When I added up all of my sign changes, remember how many there were? There were 2. When I went across, there were 2. So I know for a fact I'm going to have 2 or subtract 2, 0 real positive 0. So if I'm checking my list and I find 1 positive real 0, then I know there has to be another one. So I'm going to go find the other one. Because if there's 1, there has to be 2. Because remember, it's either 2 or 0. So if there's 1, then there's got to be 2. So this is pretty helpful. Now, how do I check for negative real zeros? Well, I'm glad you asked. Everywhere there's an x, you put a negative x. Everywhere there's an x, you put a negative x. And then you simplify. If I take negative x to the 5th power, that's an odd number, negative times negative times negative times negative times negative. That's going to give me a negative x to the 5th times a positive 2. That's going to give me a negative 2x to the 5th. If you want a shortcut on that, remember it like this. If the exponent is odd, then the x will be negative, and then you multiply that times the coefficient, which is positive, and positive times the negative is negative. Let's try that over here. Here my exponent is even, not odd, it's even. So I know that I'm going to have a positive x. A negative x times a negative x is a positive x, and then multiply that times the 5. A positive x times a negative 5 is a negative 5x squared. Then I come over here, and negative 3 times a negative x is a positive 3x, and then bring down your positive 6. So everywhere there was an x right here in this function, I put a negative x. And then I simplified. And when I simplified, I came up with this right here. Right here. Now let's see how many sign changes I have going across. Well, I have a negative sign here, and then a negative sign here, so no sign change. Then I've got a positive sign here, so I went from a negative to a positive. That's 1 sign change. Then I went from a positive to a positive, so that's no sign change. So I know for sure I'm going to have 1 or, well, hold it. I can't subtract 2 from 1. I would be in the negative 1. So I'd be in the negative number. So I know for sure that I have 1 what? Real positive 0. So I know for sure when I find my 1 positive real 0, I know all of my other zeros are going to have to be what? That's right, they're going to have to be negative. Okay? Because this function here only has 1. I said positive. Boy, guys, I'm so sorry. I apologize to you. I'm really afraid I confused you there. I'm sorry. Whenever you put a negative x in, everywhere there's an x like we did right here, anytime you put a negative x in for x, you're checking for your negative zeros. I apologize. So we had 1 sign change, and so I know there is 1 real negative 0. And I do apologize again for getting that wrong. Okay? So you need to be very familiar with this tomorrow when you work on your homework. Now, I hope I've explained this well. I don't feel like I really have, to be honest with you. And I'm sorry if I haven't, but you'll get plenty of practice. Contain your excitement in your homework tomorrow. Okay? So I hope that this has gone well. I hope you're understanding this. If you got to watch the video again or bits and pieces of it again, please do so. Don't be lazy, guys. Not that you guys are. You've been good students, but work hard and make sure you're really understanding this. Okay? No homework tonight. Tomorrow we'll have homework only. Tomorrow I will have a very quick 1 to 2 minute video for you to listen to, and then I'll give your homework to you for you to work on. And that's basically it. Call or email if you have any questions, and make sure you get your quizzes turned in today on Tuesday. Have a good day.